Hello there, and today I am going to explain how to solve problems of application of complex number. Our first problem is to determine the magnitude of the resultant force acting on the screw eye and its direction measured clockwise from the x-axis. First we will convert the image into the Argand diagram by sketching. So our first one has a 6 kilonewton with an angle of 60 degrees, and our first two is 2 kilonewtons with an angle of 45 degrees from the x-axis clockwise. So first we will draw our first one and our force number 2. We will label it as force 1 and force number 2. Then to calculate for the resultant force, that is equal to, we will use a parallelogram by drawing invisible lines parallel from the other force, and then we will draw a line from the origin to its intersection point, and that would be our resultant force. So that is just the sum of force number 1 and force number 2. So we can equate that force 1 is equal to Z1 for complex and force 2 is equal to Z2. Then we can say that our Z1 is just 6 kilonewton, but we will use an angle from the x-axis that is counterclockwise. So we will add 180 degrees to the 60 to make it 240 degrees, and that is in kilonewton. The same with the second complex number. We will subtract 45 degrees from the 360 degrees, so that is 2 with an angle of 315 degrees kilonewton. So now we can easily add the two complex numbers to get the resultant force. So that is Z1 plus Z2 equal to 6 angle of 240 degrees plus 2 angle of 315 degrees. So the value for our resultant force is 6.80 for our magnitude, and for our angle from the x-axis that is clockwise, it is 103.49 degrees. Our second problem is a ship leaves port and sails on a bearing of north 47 degrees east for 3.5 hours. It then turns and sails on a bearing of south 43 degrees east for 4 hours. If the ship's rate of speed is 22 knots or nautical miles per hour, find the distance that the ship is from the port. So we can see that the given are the direction and the speed of the ship. So first we will draw an axis for the Argand diagram. Then we have the given and the given of the speed. So we will get first the magnitude, because the magnitude is not part of the given. So we can say that in the direction of north 47 degrees east, the speed is just 22 miles per hour times 3.5 hours, and the hours will cancel 27 miles. And for the direction of south 43 degrees east, that is 22 miles per hour times 4 hours. That is 4 hours. So 22 times 4 is equal to 88 miles. Now that we have the magnitude, we can now place the direction with a magnitude on the Argand diagram. So first, the ship will sail from the port. We will label the port as the origin. So that is 47 degrees east from the north. Whatever comes first, that will the direction, and from that direction it will travel to the east with 47 degrees, and then the ship will sail south 43 degrees east. First we will label the south, and from the south we will make 43 degree angle to the east. So that is 88 miles. And we need to calculate the distance from the port to the last location of the ship. So let's first discuss when there is an angle, let's say that is 90 degrees, of that is also 90 degrees from the other side. So we can say that this angle is 47 degrees. And this, we can convert it to another the Argand diagram, and we will make the 77 miles in 0 degrees, and the 88 miles is our y with an angle of 90 degrees, since 43 degrees plus 47 degrees is 90 degrees. So we can measure the distance from that point by subtracting the two complex number. So we will label it as Z2 and Z1. So the distance is equal to the absolute value of 88 with an angle of 90 degrees minus the 77 with an angle of 0 degree. Then we can use the calculator, that is shift absolute, then 88 angle 90 minus 77 angle 0. So the distance is 116.93 miles. For our last problem, we have circuit analysis. We have two voltage sources, 20 with an angle of 60 degree volts and 15 with an angle of 0 volts. We will use a circuit analysis technique of nodal analysis since we need to solve for V1 and V2, and these V1 and V2 are what we call the nodes. So it is easier if we use nodal analysis. So in nodal analysis, we will use KCL. So for node 1 or V1, we will get the currents entering and leaving from the node. So the current entering is from the voltage source, that is 15 with an angle of 0 volts, then minus the V1 divided by 4 ohms. So we can see that is just equal to the current entering the node V1. So we will label which currents enter and leave the node. So we will assume that the current equal to V1 over J4 leaves the node, and another V2 over negative J1 leaves the node, and V2 over 2 ohms also leaves the node 1. We can say that the V2 is equal to V1 minus the voltage in the voltage supply because of the sign convention. So first, we can separate this by a variable. Then we will substitute the value for V2, that is V1 minus 20 angle of 60 degrees. So 15 angle of 0 divided by 4 is just equal to, this is equal to just 3.75. We will transpose this V1 so that the similar terms are grouped in one side of the equation. Then we can also separate these two so that V1 is separated from the constant, because we can get the value by dividing the numerator from the denominator. So this is equal to 20 angle of 150 degrees, and this one is equal to 10 angle of 60 degrees. Now let's transpose the constant on the other side. So that is 3.75 plus 20 angle of 150 degrees plus 10 angle of 60 degrees. That is equal to, and we have a common numerator, that is V1. So we can factor out the V1. So that is V1 bracket, that is 1 over 4 plus 1 over J4 plus 1 over J1 plus 1 over 2. Getting the sum of the constants, that is equal to 20.53 with an angle of 114.67 degrees. And also simplifying on the other side, that is 1.06 with an angle of 45 degrees. So now we can get the value of V1 by dividing 20.53 with an angle of 114.67 degrees by 1.06 with an angle of 45 degrees, and our V1 is equal to 19.35 with an angle of 69.67 degrees. And for our V2, we can use the previous equation, that is B2 is equal to B1 minus 20 angle of 60 degrees. So substituting, that is 19.35 angle of 69.67 minus 20 angle of 60 degrees. So for our V2, the value of V2 is equal to 3.38 with an angle of 165.79 degrees, and the unit is volts. In this module, I learned how to apply the lessons from the previous modules on different situations, such as in physics or in circuit analysis. I learned how to get the resultant force by adding the two complex numbers and the distance between the 2 points by subtracting the two complex numbers.